Very good afternoon, everyone. Myself, Avinav Singh, and I'm currently pursuing my bachelor's in software engineering from SRM Institute of Science and Technology. I'm currently in my final years, and in this video, we're going to talk about neural networks. What are they? What are they used for, and what are they capable of doing? And in what field and or in what sense we use it. So basically, if you have zero knowledge about it, or even if you don't have any knowledge about it, today we are going to talk about it, and we're going to understand what it is, and on what purpose it is used. So basically, you need to listen very carefully and just keep everything aside and just try to link different parts of whatever I'm trying to say. First of all, what is a neural network? Neural network is basically a type of deep learning or machine learning model. So, neural network is that type of machine learning model which mimics the neurons in your brains. Your brain has a neuron, and if you have seen the basic structure of neuron, it has dendrites, it has then a string like structure called the axon, and then it has nerve endings. So basically, it has three parts. First part, it has dendrites, and in that, it has cell body, and then it is attached through a string like structure called the axon to the nerve endings. So how it works? Your brain gives an electrical signal from dendrites. Dendrites receives the electrical signal, and then cell body process it, and through the axon it sends it to the nerve endings, which leads to transfer of it to the another neuron. So this is how it works in your neuron. So what a neural network does, it basically mimics that particular complex pattern of neuron, and plays a process those data. For example, a neural network, imagine neural network like a three-layer model. It has three layers. First layer is the input layer. Input layer, the main job of input layer is to take the input. Whatever input, whatever data you are giving, whatever image you are giving, the sound it is receiving, whatever data that could be of any type. So the main job of input layer is to receive those data, and when input layer receives those data, it sends it to the another layer, that is the hidden layer. What's the main job of hidden layer is to process those data, all the processing, working on that hidden layer, whatever the functionalities, extraction of data, and cleaning, pre-processing, everything, whatever happens, whatever data extraction happens from your data, it happens in that hidden layer. And then the last layer is the output layer. This is the mental model that you can imagine about the neural network model. Now, the net input layer and the hidden layer are connected through certain connections. Those are called those are the connections, and they have certain weights and biases. Now, don't worry about these terms. What weights and biases are basically, weights are basically consider as it as an importance you are giving to each input. For example, you give each input, there are four inputs: A, B, C, D. So these four inputs contain different importance. For example, A may be very important to you, B may be very bit less importance, C will be even lesser, and D is of no importance. So weights are the values that you multiply with these inputs. So weights basically has, for example, higher the importance of an input, the higher the value of the weights. For example, if something A has the higher importance, so the weight value of that particular input, that particular connection will be higher. C has or D has very less importance. So the weight value for that connection will be even lesser or almost equal to zero. Biases we're gonna talk later on in our video. First, we're gonna understand these things. So weights are basically the importance. Understand, weights are the importance we are giving to our inputs. So one thing, you know that if the importance is high, then the value of weights will be high. If the importance is low, then the weight value of the weight will be very less or even lesser. Now, second one, comes that hidden layer. So all these inputs and weights are taken into hidden layer to process them. Now, what happens inside this hidden layer? What are the things that are happening there? We're gonna try to understand them. First is whatever data you have taken. So understand this about neural networks. Whatever data you give to the neural network, either be it image, be it data, be it sound, or be it any kind of text, doesn't matter. Whatever data you are giving to the neural network, it converts them into numbers, right? So it does not play with your sound. You give the sound and you give image. It doesn't play with sound, it doesn't play with image, it doesn't play with text. Whatever data you give it to, it will convert it into numbers. So once you give these data to your neural network model, it converts them into numbers, and in those numbers it identifies the patterns. It identifies the patterns and it differentiates those patterns and understand those patterns to get to the final output. For example, there is a thing like you give an input. You give input, hidden layer process it, gives output. You understand these three things? You give input, hidden layer process it, and it gives the output. This one way movement of the data, this one way particular movement of the data, we call it the forward propagation. This is called forward propagation. So understand these things before understanding this completely. If you did not get it, try to understand. There are two phases in the any kind of model training. There are two phases. For example, first is the training phase, and another one is real phase. What is training phase? Training phase is a phase where we train our model. We give labeled data, which is basically a supervised learning kind of learning. So we give labeled data to a computer, and it process those data. For example, in training phase, what is happening? You give a particular set of input, and you give your computer process it in hidden layer, and it gives a particular output. Okay, now that particular output, what the model will do? Model already has a labeled data in the training phase. Understand that this is the key factor. Model already has a labeled data, that what is the right answer, what is the wrong answer. Model already has that data in the training phase. We give it to the model. So whatever the answer that we got, model matches that answer with the real data it has. If the answer matches, well and good, your model is perfect. And if answer does not matches, then what happens? A thing called back propagation. What back propagation does, if the answer is not matching, for example, the real answer is 1 and your model is getting 0.2. Okay, so your model is still way far for being a perfect model. So whatever value it got, it will go back again to the processing phase, that is hidden layer phase, and it will process it completely. For example, it will shift those weights, it will shift those important weights, and it will shift the values in such a manner that it becomes closer to the real value. Here, you need to understand what is a bias. Bias is basically that value which we add to our product of input and weight plus bias. So bias is basically that value which we add to bring that particular output closer to the real output. And optimizer is basically understand optimizer as a knob. You have a knob, so you turn the knob right and left to increase or decrease the values. So bias is something that is happening, that the value, and knob is the knob of that bias is what we call optimizer. Job of optimizer is to increase or decrease the bias to make it equal to the correct output. So once the back propagation happens, your value was 0.2, but it needed to come to 1. So it's still very far. So it will go through the whole process of hidden layer output, whole process again, then it will give the output. Now your value comes out to be 5. Yeah, we came